I think we're all ready to go now. So my name is Jack Young and I'm a research manager at CIRIA. Thank you for joining us for today's launch of the newest guidance screening coastal infrastructure through eco-engineering. Before we begin, I do need to go over a few housekeeping points. So for those attending now in person, there's no fire drill as far as I'm aware planned, and the assembly point, if there is an alarm, is just outside the foyer, just past the plaza and outside the park building. And toilets, if you've managed to find them, they're just outside the door on the left and the immediate right, just past the elevators. For questions, we're going to be taking questions after all of the presentations are finished. So if you do have one during the presentations, just keep hold of it. Don't wave your hand around because it might distract speakers. And for online attendees, you're viewing the event in a listen-only mode. And if you have any problems with your connection or audio, then raise your hand or send the CIRIA team a chat message and one of us will be there to help you out in the background. For the Q&A session, there is a Q&A box. You should be able to submit your questions and interact with each other's questions just to upvote and make us aware of which ones are some of the more popular ones. If you wish to receive CPD for this event, there's going to be, for online attendees, there'll be a poll that will pop up towards the end of the webinar. Or for you, it's a webinar, but for us, it's not. And for the people in person, that you'll be sent a post-event survey that you'll need to complete to receive the CPD. We'd also really appreciate throughout the day, if you do happen to take pictures, especially on the site visit, make sure to post them on LinkedIn and tag us, because we're always trying to increase our presence online as well. So just a quick introduction to CIRIA for those that may be tuning into an event for the first time or in person again for the first time. We recently celebrated our 60th anniversary as a not-for-profit member-based organisation. Our core strength really is improving performance through collaboration in the built environment and construction sectors. And typically we do this by producing, like today, authoritative, independent, good practice guidance on a range of different topics, such as the SUDS manual is one of our most popular ones, the ROC manual, beach management manual, and get guidance on biodiversity net gain, to name just a few. We host around 50 events per year, mostly online, and these can range from topical conferences, annual debates, lectures, webinars, and seminars celebrating guidance like today's one. We are a small but growing organisation with around about 80 corporate members. Many of these you can see on the slide here. I would like to quickly say thank you to the funding organisations for this project. You've really been essential throughout the development of this, from the early scoping workshops through to the draft reviews and the inputs to case study materials. So we really wouldn't have been able to produce this document without you, and just wanted to say a quick thank you for your continued support. Got a really interesting programme for you today. So really what we're aiming to do is to obviously celebrate the guidance and explore how coastal eco-engineering can benefit the construction industry and bring together experts like yourselves in asset management, biodiversity and geomorphology to really help achieve the UK government environmental guidelines and expectations and targets moving towards a more sustainable future. So in order to do that, we've really got an interesting programme, and I'm delighted to be joined by our speakers, with Larissa Naylor from the University of Glasgow and one of the co-chairs of this project, Joanne Harridge, the lead author with the guide from HR Wallingford, Emma Hipp from Haskoning, Anira Jones from McDonald, and Lucy Sheffield representing Coastal Partners from Haven Borough Council, and Nikolai Rotterman from the University of Portsmouth, who we're very thankful for hosting us today. So without further ado, I would like to introduce the first speaker, which is Dr. Larissa Naylor. It's a professor of geomorphology and environmental geography from the University of Glasgow, who's going to help set the scene, and she's kindly provided a quick 5-minute pre-recorded message as she couldn't be here today. So I believe this should play in a second.
Good morning, everyone. My name is Professor Larissa Naylor, and I'm delighted to set the scene for this guidance this morning. And a very large apology for not being able to be present in person. It's the school holidays here in Scotland, and my husband's in China, so I'm in Glasgow. So I'd like to welcome you to the day. It's a wonderful opportunity to celebrate this field really maturing to a stage where we have the first UK industry guidance. This field has been emerging for a number of years, and it's been developing and blossoming, and it's been amazing to see all of these wonderful companies and applications of this work around the UK in this field of eco-engineering that is used to green the grey. And it's used where it's not possible to use more nature-based solutions. So maybe in our more urban areas or areas where we choose to defend or alleviate risks using conventional structural assets such as sea walls. And eco-engineering is a way of taking those grey infrastructure assets that have to remain grey for their primary function and trying to green them in a way that enables ecology to exist alongside the primary engineering function of the assets. So these applications that are in the guidance are designed to improve ecological effects and benefits, and they can deliver multiple functions for people and wildlife, not just in terms of biodiversity, but they may have cultural or provisioning benefits, such as providing food for prey species of birds or sites for nursery fish. And as an example of this, there's a number of policy drivers. The UK government released their 25-year environment plan, and we've had a rapid change in the policy landscape, including biodiversity net gain, which is coming on stream, which this guidance is perfect to help practitioners support implementation of. And it's also in terms of coastal and flood risk management, is that in Welsh policy, a number of us worked very hard to support the Welsh Government in making this policy change. So their business appraisal requires consideration of greening the grey before going to a grey, standalone grey solution as part of flood risk management. And the original guidance that I led on in 2011 needed updating. And this CIRIA guidance brings together expertise from industry, from practice, from government, from the regulators, as well as the academic community, and it really pulls this all together in one place. And so the scope of the guidance, it sits alongside working with natural processes and nature-based solutions. And we're here really talking about the green, grey and the hybrid features. And so there's real opportunity here in the UK because the length of this more artificial or engineered coast is approximately 15% of the coast. The guidance is high level. It provides UK examples or examples suited to the UK and includes the coastal and estuarine habitats only. And it is designed to support engineers, ecologists, geomorphologists, planners, people making financial decisions on projects. It's designed to support everyone who's involved in an engineering project that could lend itself to greening the grey. And I really wish the launch today every success. It's wonderful to see you going on site, to see some of these examples firsthand, and to be with some of the really passionate pioneers in this field from the practice space, like Lucy Sheffield. So I welcome you and enjoy, and we look forward to hearing how the guidance is used, and we hope it is a catalyst to move from an area of widespread innovation to widespread application, so it becomes normalized as part of engineering and related construction practices. Thank you.
Thank you very much, Larissa, for providing that and pre-recording it in time for the session. So I believe we're now going to hear from our next speaker, Joanne Herridge, who's an Assistant Project Manager at HR Wallingford and lead author of the guide, alongside Emma Hicks, the Principal Engineer at Haskoning, who are going to be giving us a deep dive into the guide and what you can expect to learn from it as well. So if I could invite Jo to the stage.
Yeah, so hi, I'm Jo Herridge from HR Wallingford, and myself and Emma are just going to take you through some of the main topics that are included in the guidance and just give you a bit of a flavour about what's included. Okay, is there a microphone? There is.
I can up the microphone max up, so just
Okay.
you might just have
I'll
to
shout
speak in
into
it.
it.
Yeah.
Okay. So just to introduce you to the project team, so the author team made up of HR Wallingford, we were the lead authors, and we're working with Haskoning and Hades, who authored some of the individual chapters. And we're also supported by independent consultants, Steve Challoner and Larissa Naylor, who you already met. And we had a project steering group that was co-chaired by Larissa and Brian Curtis. And it was made up of all these organisations that you see listed here. So thanks to everyone there who's involved in the reviews and comments throughout the process. I think we had quite a nice diverse range of different organisations there, some coming from a more engineering background, and then others from more of an environmental management or ecological background. And we are also pleased to have received endorsement from the UN Ocean Decade Project. So it just highlights the links there with the UN Sustainable Development Goals that are related to ocean science. So what is eco-engineering and why are we doing a guidance about it? Well, we know we have this issue of ocean sprawl, which is the proliferation of artificial structures in the marine environment, and that can result in the loss and alteration of coastal habitats. And the conventional coastal infrastructure that's put in its place often has smooth and level surfaces, limited habitat complexity, and lower biodiversity. So we see there's a need for a more ecologically sensitive design of artificial coastal structures, and that's where eco-engineering comes in. So as Larissa explained, eco-engineering is the addition of these innovative features into the design of coastal assets to provide benefits to the local ecology. And it's often called greening the grey. So by greening the grey, we're aiming to improve ecological effects, and then you have a structure that delivers functions for both people and for wildlife. And so just go over the scope of the guidance. So it very much sits in this green-grey space there. So it's for, you've probably seen a diagram of this before in Larissa's slides. You've got the conventional engineering on one end, and then the natural habitats at the other end. And in between, there's a whole range of nature-based or green-grey solutions that you can employ in a coastal context. And the guidance very much sits within this green-grey space there. So it's for instances where the other more natural or greener nature-based solutions are not applicable for whatever reason, or maybe there's already a grey structure in place. So it's not meant to replace the nature-based solutions, it's meant to be complementary to them. In terms of the focus of the guidance, it's a high-level guidance document focused on the UK, but it does include examples outside of the UK where they're relevant. And it's focused on the coastal and estuarine intertidal habitats. So it doesn't include rivers or offshore. It's very much focused on the coastal opportunities. So why is now a good time for the guidance? Well, over the last 10 years, there's been a rapid advancement in the science, policy and product development related to eco-engineering. So we have a growing body of academic and industry trials and evidence of applications and their success to build on. But at the moment, it's not particularly widespread in industry. It's led often by these enthusiastic and dedicated teams or individual champions. But it'd be nice to bring it to a more widespread application and seen as a viable first option rather than just a nice to have. And there is lots of guidance out there already about nature-based solutions. But as we said before, green and grey is recommended in place of grey engineering solutions where other nature-based solutions are not suitable, and also where it's ecologically appropriate. So these are some of the main project goals. We wanted to build upon existing guidance documents, such as CIRIA and NERC's collaboration in 2017, and update the examples given there to really highlight the art of the possible when it comes to coastal eco-engineering. And to do that, we look at the evidence, the design and the application of the methods, and use that to provide recommendations of how these designs can be applied in typical UK coastal settings. We also wanted to look at some of the asset factors, so things like the asset lifecycle, monitoring and maintenance, and also the business case, so looking at how to build an effective business case, and also looking at some of the costs and benefits and policy considerations there. And one of the key things we wanted to do was inspire the target audience. So that could be asset owners, engineers, coastal ecologists, or any other stakeholders involved in the design, construction and management of coastal infrastructure, and give them ideas about how eco-engineering could potentially be applied in their fields or in their projects. So this slide is showing an overview of the different chapters we have in the guidance. What we're trying to do is really answer these questions of the what, where, when, how, and why of eco-engineering. So we start off with overview and context. And the next chapter is about environmental and natural processes. So this goes into a bit more detail about some of the typical UK coastal habitats, and also some of the environmental, geomorphological, and ecological processes that go on in those. And it's important to know about this because it'll help you to design eco-engineering techniques that are applicable and successful for those particular habitats. And we look at the assets themselves, the range of different techniques that you can apply onto those assets, and also some of the design considerations about how to apply these techniques. And then we look into the business case, how you include eco-engineering in the business case. And throughout the guidance, we've tried to include quite a range of different case studies. So we've got sort of smaller snapshots of case studies throughout the guidance to illustrate particular points in the text. And then we've also got more detailed case studies at the end to give a bit more detail about these projects and really dig out some of the successes and the lessons learned from each one of those. And then finally, we get the gaps and recommendations. So any gaps that we found as we've been researching, and then some recommendations for potential actions to hopefully facilitate the uptake of eco-engineering in the future. So looking at the assets themselves, we had a look at the different types of coastal assets that you find around the UK. And really you could potentially apply eco-engineering to any of them, as long as it's appropriate from an ecological and asset management standpoint. So we've sort of divided them into these 7 main groups here, which are loosely based on the Environment Agency's asset management database. But you have probably the most common ones that you see eco-engineering applied to are these linear structures, sloping and vertical linear structures, such as seawalls and breakwaters. But there's also potential to apply it to other types of structures. So for example, mooring structures like piers and jetties, or scour protection around coastal structures, or even utility structures such as cables, outfalls and pipelines. And we looked at the opportunity in the UK, and estimates suggest the length of the artificial coastal edge is around 15%. So we see there's a big scope of opportunity there for more widespread uptake. And when thinking about the assets, you need to consider the asset lifecycle. So there's a simplified version of that shown here. And we see that you can include eco-engineering features really at any stage within that lifecycle, depending on the project. So if it's a new construction, you probably want to consider it during the early stages, during the scoping, planning and design phases. But there's also techniques that could be retrofitted onto structures. And these could obviously be applied on existing structures, so it could occur anywhere in that lifecycle. And there's also opportunities within the regular repair and maintenance cycle of an asset. That could be an opportunity also to introduce eco-engineering. And throughout this, you need to consider the asset performance factors. Obviously, the eco-engineering features, you want them to perform from an ecological perspective, but also bearing in mind the intended engineering performance of the asset and make sure that's not affected. So looking at the techniques themselves, so we looked through all the different techniques that are available in the market, in the literature, and in the case study examples. And we found this idea of habitat complexity was really important, and it ran through them all. So habitat complexity being the diversity of structures, resources and niches that are present in an ecosystem. And you find that more complex habitats will typically support a greater species diversity and abundance. There's increased opportunities there for shelter of organisms and areas for colonization. So if you think, for example, of a natural rocky shore habitat, it's going to have much higher habitat complexity than, say, a concrete seawall. So that's what you're doing with these techniques, is trying to make it a bit more similar to those natural kind of habitats. So we looked at all the different techniques, and we divided them into these 5 kind of main groups here, shown in the table. So we've got textured surfaces, for example, the addition of textured blocks and tiles, or the creation of grooves, pits and ledges in the surface. Water retention structures, so that could be artificial rock pools or holes and cavities in the surface that retain water. And swim-through habitats, mainly relevant in a subtidal context, so that holes and crevices within a structure for organisms to live and hide in. Macro habitat features, so anything that is attached onto the structure to provide additional substrates, such as vegetated wall modules, ropes and twine. And then finally, environmentally sensitive materials. So thinking about using ecologically sensitive and bioreceptive materials, and also avoiding toxic surface treatments. So there's a variety of different techniques you can use, and often in the project case studies we looked at, they would use probably several of these techniques. Another thing we look at is the design considerations. So what do you need to think about when you're designing the eco-engineering techniques? For example, knowledge of local conditions, considering baseline ecological and geomorphological surveys, so you know what environments you're working with. You can also use that to measure performance against. Considering ecologically suitable and sustainable choices of materials. Installation, so how do you actually fix or incorporate the features, the eco-engineering features onto the structure, as well as timing can be important. If, for example, you're targeting a particular species, you might want to think about the different settlement periods for that species. Spatial distribution, referring to the arrangement, and also importantly, the positioning in the tidal range. So obviously different techniques are going to be applicable at different areas in the tidal range. And maintenance and monitoring is an important one, looking at how do you go about monitoring the biodiversity impact of these eco-engineering features, and also how do you incorporate that into the regular asset inspection requirements, and maybe there's a need to adapt the methods there that you're using. Invasive species is kind of linked into that one, making sure you're monitoring and recording any invasive species to make sure you're avoiding any adverse impacts from that. And then the last one, public engagement and safety. So a lot of these coastal structures are in public places, they're accessible. Beaches and seafronts obviously widely used by the public. So there's an opportunity there for additional education and outreach activities, making sure you're including all the key stakeholders then, as well as public safety considerations such as access and signage. So you might want to put up signage to inform people about what these eco-engineering features are doing. So all of these considerations here are really just to make sure that you're designing eco-engineering solutions that are as successful as they can be, and that you're deriving all of the intended benefits from them, and also possibly some additional benefits as well. So yeah, talking of benefits, that leads kind of nicely into the business case development. So Emma will take you through that.
Hi everyone, I'm Emma Hick from Haskoning, and I'm just going to take you through some of the business case side of the guidance. So business cases, they're the process through which a project should be developed in order to ensure a successful outcome. Regardless of the type of eco-engineering project, whether that's a standalone retrofit type project or part of a bigger project to construct new assets, it's important to understand how the specific requirements of the eco-engineering measures fit into the business case model. So the UK government's preferred process for developing projects is the 5-case model. And this covers all aspects from understanding the need for the project through selecting the best option, how it's going to be procured, how it's going to be funded and delivered. So the new CIRIA guidance provides advice on each of those cases in terms of the things that need to be specifically considered for eco-engineering projects. So for the strategic case, the guidance provides advice on how to build eco-engineering into the case for change and the project's objectives to really drive buy-in from key stakeholders and funding organisations right from the start of the project. This is really key to getting the eco-engineering embedded into the project rather than just an add-on. For the economic case, the guidance provides advice on how to assess the benefits of the eco-engineering measures and how to ensure the option appraisal and decision-making process really takes appropriate account of eco-engineering within sort of the context of the wider project. For the commercial case, the guidance provides advice on the types of things to consider when planning the procurement and the contractual matters for the project. And for the eco-engineering, this might be different to the rest of the project and therefore needs some special consideration. The financial case is really key to ensuring the consideration is given to funding the whole life cycle of the eco-engineering and not just the installation. So this is particularly important to consider how any ongoing monitoring and evaluation will be funded. And for the management case, this provides the guidance provides advice on considering how the benefit realisation and the post-project evaluation and monitoring regime. And again, this might be different to the rest of the project. And it also considers who's going to have the ongoing responsibility for the eco-engineering and what to consider for contingency planning in the event that it doesn't perform as predicted. So as part of the strategic case, it's really important to set the eco-engineering to the strategic context to understand why it is needed and not just that it's the right thing to do. So this starts by looking at the national level policy drivers, such as the biodiversity net gain, amongst others. And there will be policies and plans and strategies at all levels, from the national to the regional to the local level, which can support the inclusion of the eco-engineering measures. The new CIRIA guidance does provide a list of examples of the different types of plans and policies and strategies that can be used to help justify the inclusion of eco-engineering. But there also needs to be the consideration at the project specific level rather than just the generic level. So it's really important to also look at the business level plans and objectives of the organisation that's proposing the project, as well as of the key stakeholders and the funders. And this really ensures the buy-in and integrating the eco-engineering into the overall project. And some of the policy drivers for a project will be the same as those which have driven the development of this guidance, as Larissa kind of explained a bit earlier. So these include sort of the national level environmental guidance goals around biodiversity and water quality, as well as things such as the Welsh Government requirement for nature-based solutions and the recent requirement for the biodiversity net gain for new developments. So the new CIRIA guidance also provides information on how to assess the benefits of eco-engineering measures and the different approaches which might be appropriate to use. There are many different ecosystem service benefits that you can get from these eco-engineering measures. And it's really important to understand the sort of specifics of what your project will actually deliver. Where possible, these should be quantified and monetized, and the new guidance will signpost you to various sources that will help you do that. Where it's not possible to quantify benefits, it's important to assess those qualitatively. And it's really, really critical that the benefits are linked back to that original case for change in the strategic case, linking back to the business strategies of the different stakeholders and the funders, and really critically to showing how the eco-engineering measures will help fulfill the project objectives and critical success factors. So finally, the guidance document includes case studies examples sort of throughout the whole document, showing where different types of eco-engineering measures have been delivered, and this is to provide sort of real-world experience and inspiration for your projects of how to apply the guidance and incorporate the engineering measures into projects. So this includes sort of the North Portsea Coastal Scheme, where the site visit is this afternoon, and which Lucy from Coastal Partners is going to tell you a bit more about a bit later on. So thank you very much. We hope this new guidance will sort of inspire and support the development of your projects in the future.
Thank you so much, Joanne and Emma. It's really nice to see actually good examples of how the guide is going to play a part in the industry. And there's so many case studies in there that you can look through when you read it yourself. So we're now going to hear from our next speaker, Inira Jones, from Marine Environmental Scientist at McDonald, who's going to take us on a bit of a virtual trip to the other side of the country and speak about the coastal defences at Colwyn Bay in Wales and how eco-engineering principles have been applied, and a look at some lessons learned. So, yeah.
Yeah, hi, my name's Anira and I'm a marine environmental scientist at McDonald. So I'm going to cover the Old Colwyn Coastal Defence Scheme, but first I'm going to talk a little bit about McDonald, who we are, then I'll go on to a bit of background, the eco enhancements that we integrate into the scheme, and then round it up with some sort of challenges and lessons learned. So McDonald is a global employee-owned consultancy. I sit within the marine environment team, and we're spread out across the UK. We're quite a small team within a larger organisation, and I'm based out of the Colwyn Bay office. So actually, this site is probably the only site I've had the opportunity to be able to walk from the office to survey. I also have the opportunity to be involved from detailed design right through to construction. So I'm kind of wearing two hats. So my first one, I was involved in the environmental assessments under detailed design, and then I was actually seconded part-time into Common Council. So helped with the installation and now the monitoring of these. So, Old Colwyn is located along the North Wales coast. It forms phase 3 of the larger Colwyn Bay waterfront project, which is overall a kind of regeneration in addition to a coastal defence. So it's kind of aimed to improve the amenity value of the area. So as you can see, Old Colwyn is subject to regular overtopping and damage during storm events. So that meant that the prom and air road was subject to regular closures. Although it doesn't protect properties, it does actually have the North Wales Coast Railway line and the main road across North Wales directly behind it. So it was important to maintain this. So it was split into 2 areas. Area 2 has been constructed today. Area 1 is actually still waiting funding, so hopefully it's important to get that done. McDonald and design, as I've already mentioned. Conway County Borough Council was the client, and then it was funded by Welsh Government and constructed by Alan Griffiths. So it involved the construction of a new rock revetment and then extensions to groins and outfalls. Also raised the promenade to improve flood resilience, and then there were improvements to the cycle path and prom. There were also landscaping and public realm improvements, so we installed a fishing platform. There was access improvements, so there's 2 new access steps. There is an accessible ramp proposed for Area 1, and then there was numerous ecological enhancements which we covered this soon, and then an outdoor classroom and picnic area which also forms part of Area 1. So yeah, third iteration of this slide. Why eco-engineering? So traditional coastal defences are smooth, vertical, and subject to drying out. As you can see from this image, that was the original seawall before the rock armour was installed. So harsh and hostile environment with low biodiversity. So eco-engineering adds microhabitat, provides rougher surface textures and water retaining features, which means it's more colonisable surfaces and more biodiversity. So we had tide pool units integrated into the new revetment. So these were all positioned so that they were water retaining. We also had ecological armouring units. So we've got 2 existing rock groins that go out, and we had 2 on each of these. So we positioned one so it was flat and the other one so it was angled, just to see kind of how they worked. And then we also had verticals These were installed on the east side of the access steps because prevailing conditions at Old Colwyn is from the northwest, so sheltered side, and clustered in kind of 5 each one. Also had enhancements to the new revetment that was installed. So we had drill holes, pits and striations to kind of enhance the rock that was there. On that actually, the rock armour we tried to source locally. So about 90% of the new rock armour was sourced from quarries local to North Wales, so within a 30-mile radius. And there were some rocks already there. They were regraded and reintegrated into the new revetment. The filth raised in the promenade as well. That was sourced from other construction sites that Alan Griffiths operated. So otherwise we've gone to landfill, so used and recycled. We also have textured precast walls installed at the base of the kind of access steps. So they only got installed a year ago. So results so far, there's an increase of from 12 to 27 species on the eco-engineered units compared to the unenhanced sea defences. Despite being the smallest, the vertical showed the highest increase in species richness. Another one is blue mussels were noted to be present on the eastern ecological armouring unit. This is notable because historically there was a blue mussel bed mapped in the eastern end of the scheme, but when we did the pre-construction surveys, these weren't present. So it just shows that they're actually working and bringing them back. And the eastern ecological armouring units support a higher species richness than those in the west, and that is kind of the general case across all of the enhancements put in, and I don't really know why. The only negative, the invasive barnacle, Strominius modestus, was recorded on some of the rocks, but this was in the limits. And the pretty stuff. So, some of the species that we've encountered, we've got henpen, really pretty green sort of fern-like seaweed. That was in the ecological armouring unit at the low shore in the water retaining structure. We also had sea slaters on the upper shore, so on the tide pools. Blue mussels I've just mentioned. Varying hydroids. These were, I think, more limited towards the low shore enhancements. And then springtails. They were in the upper shore in the kind of water retaining structures. And also juvenile common shore crabs and things. These were in the verticals on the seawalls. And some more. So varying paliforms of anemones. A rough periwinkle in the end there, and then it might be quite difficult to see actually. The shrimp is swimming towards the camera, so it's quite well camouflaged, as is the common goby, very well camouflaged amongst the sand, so you see its head on the right there. So, what's next? We're going to continue managing monthly, so hopefully get us a total of sort of 2 years of ecological data. Also going to install an information board because actually we've done all of these really nice enhancements and nobody knows they exist. Okay, answer challenges, lessons learned. So there were some challenges. The specification for the enhancements was an appendix to the main construction works. So going forward, we need kind of more detail as to when and how to install these in relation to the wider construction scheme, as opposed to not just what. So we're aware of what needs doing, but in terms of the timing of when to do it in kind of amongst the rest of the construction works. So for example, the enhancements to the rock surface, which is included inside there. They were very keen on placing the rock revetment before putting the enhancements on them. So it would be useful going forwards to have them say, right, these enhancements need to be put on the rocks before they're then placed in a revetment for health and safety particularly. Another one was changing attitudes in education. So the scheme provided the opportunity for upskilling of contractors and having a positive attitude towards the enhancements enabled successful implementation of this. But yeah, educating the benefits the ecological enhancements would provide was important as initial reluctance to adapt the standard working methodology, particularly in kind of challenging conditions. I mean, the scheme was limited to front, so that compound was on the prom. So in storms, the overtopping was hitting their works compounds. They were having to kind of chuck everything in storage compounds to protect it during storm impacts. They were already behind schedule. And then access issues. For me to survey these, it's been quite awkward, especially because like the higher up vertical tide pools are harder to get to than obviously the lower down ones. So there is the potential for under-recording of species on my part, especially you can see the ecological armouring unit. it's hard to see around the outside because they're really clustered, which is really good for species because they're nice and sheltered and tucked away, but not so good in terms of identifying them. We also had grates on the specification. Now, going forward, if we do this again, I'd keep them on the sides, but actually the ones on the top haven't really added much. It's just made it harder to survey. So things like an endoscope would be a good idea to kind of do. And then considerations for installing on dynamic sandy beaches. So it is a dynamic environment, beach levels do change. So the photos on the right there are for from June, I think. The precast wall is underneath the sand and the verticals are just sticking out. So it's not all bad. They will come back when the beach levels lower again. And they are still providing more habitat than the actual seawall they're attached to. So to continue on from that, using the tide pool as an example, that tide pool is on the base of the revetment, so it's got no protection at all from the other rocks. That one is located a little bit higher up, literally only a meter, and then the difference in colonization. Not to say again, this is bad. It does still provide additional habitat of what just the bulbous provide. It's still got water retention and it's got a sandy bottom substrate. So how are we applying these lessons? So using them to inform future schemes. So under my council's comment, I'm already in conversation with the construction contractor at a site just a little bit further east at Kimmel Bay, and we are already enhancing the rocks before they're being placed. We've also provided additional guidance on kind of the angle, where to place them to kind of shelter, because it specifies 20% coverage of the rocks, but 20% on the north side would be subject to kind of increasing scour, so we're kind of aiming them so they're more sheltered. We're going to incorporate lessons learned in the way features specified within tender documents, and also going to start taking into account local conditions and factor of climate change in terms of considering where to place these. Early engagement is also really important, so educating everyone involved. Sorry, my voice is going. Yeah, educating everyone involved into the importance of enhancements and the wider benefits they provide. And considering actually that they don't have to be installed at the very start of design, they can be retrofitted. So some wider benefits. The project received a sequel outstanding rating for its strategy and design phase because it integrated climate resilience, resource efficiency, and ecological enhancements from the outset. And then to finish off, these are just some pictures of the Colwyn Bay waterfront as a whole. So the East End was predominantly aimed at improving kind of ecological benefits of the area. This end was also amenity value. So this is more to the west. So we've got showers, new kind of play features, like kind of servicing station, and then seating and stuff. Yeah, thank you for listening.
Thank you very much, Amira. So now we're going to hear from Lucy Sheffield, who is representing Coastal Partners, and she's the Coastal Environmental Project Engineer, and is going to help set the scene for the site visit later today, exploring some of the eco-engineering, the local eco-engineering at the North Portsea Coastal Scheme. So over to you, Lucy.
Yeah, so I'm Lucy Sheffield and I work for Coastal Partners. So it's a local authority based. We cover 5 local authorities along the coast in Hampshire. I'm going to be a bit cheeky and talk about 2 schemes. We've got the South Sea scheme, which is the largest local authority-led scheme, and then I'll go on to the Eco Formliner project. So this is the largest, one of the largest local authority-led schemes in the country. It's a £148 million scheme over 10 years. And I'm just going to focus on, just give you a little quick example of the eco-engineering that we did at South Sea Castle, which is just on the coast here. This is a very old picture of South Sea Castle, and you can see at the bottom there how the defences were collapsing and we really desperately needed to do something. So around South Sea Castle, we've got these birds called purple sandpipers that they use the rock revetment there and the only place in Hampshire that they both roosted and feed. So as part of the scheme, we needed to like mitigate their impact. So one of the things we did was we used seed rock. So in the top picture where you've got the two machines there, they were picking up rock that was already colonized and moving it to the front of the new revetment. And you can see the line of it in the bottom picture there that's colonized. And the aim of that was to kind of speed up the colonization process to allow seaweeds to grow so that they had something to feed on. And we're really pleased to say that they're back to pre-construction levels now, the numbers of the purple sandpiper, so that was good. And you can see the revetment in the bottom corner there and how it's colonized really quickly. We also put precast tide pools in. We had 45 tide pools put in, and we also trialed rock munched, which is my term for digging out pools within the actual rock, the larger rocks themselves. And we tried that, putting both the rock munched and the pre-cast tide pools in one area to see if it made a difference to do the two, because they've got very different requirements putting them in. And we had an independent survey done from Jess, who's here today, and basically they said that that was in last summer 2024. It was an independent survey, and it concluded that the combination of enhancement techniques has resulted in a diverse community and is highly recommended that these techniques should be used in future schemes. So that was really good. But we'll go and see that one later on. The main one that I wanted to talk to you about was the North Portsea Coastal Scheme. It's 8.4 kilometres of defence. It's 10-year build and £87 million, and it's increasing the standard of protection. But the main area I'm going to talk about is a little bit in purple there. So we did it in phased construction, and in this area here, we really wanted to look at different alternative ways of working. So I'm really going to focus on explaining about the eco-formliner and the high tide wader roost island, just to give you an example of two different ways that you can really do eco-engineering. But we've also done lots of other things. There's always a solution, so you can do lots of things. So I started with the eco-formliner. So we started off, we wanted to do something different. One of the previous phases was a very smooth seawall, and we could see that it was not really enhancing the environment. On the coast, it was very heavily designated, and behind we had a lot of infrastructure. So we had to do a vertical wall. That was our only option. And we started to look out if there was something on the market to cover the whole height of the wall, and it's 3 meters high in places. So there was nothing that we could kind of cover the wall with to create some kind of enhancement. So we looked at research and found Larissa and her work at Glasgow University, and based it all on her PhD research with Mari up at Glasgow, and particularly this study here in the Singapore tile, which is the one with lots of holes in. And we basically based the formliner on that and developed it. And then we spoke to formliner companies. So it's actually creating texture on the wall itself rather than attaching anything to the wall. But we needed to check that the formliner itself could withstand this. Usually they're vertical things, so when you release it, it's kind of easy. So this was texturing horizontally to try and hold just small amounts of water in the wall. So we tried that. We did a small mold, and that worked. It's striking out, and that's the kind of the texture on just this small little block to see if it would work. And then we got funding to do a full-scale trial, and we tested out 2 formliners. So we did the eco-formliner, and we did a contractor safe one, so to show that the contractors, they were happier with that one, but we wanted to try and push the boundaries. So we did both. Everybody was happier with the way that this one turned out, and it was much better for the environment, so we decided to go with this one. So that was the kind of texture of the result at the end. That was just in the car park, because the construction is actually within the intertidal, and we needed to make sure that it wasn't going to slow up progress, because very tight timescale for doing the works. we started in 2021, carried on till 2024. We could only work in the summer months because of the overwintering bird period. So we had a lot of turnover of staff in that time. So we did a lot of toolbox talks to show how to do the, and videos and stuff to show how to do the prep of the form liner to make sure we got the consistency high. This is a smaller at the top there, a smaller mold, and we created it that it could be cut into different sections to facilitate the different design of the wall as it goes along. So some areas it's got this kind of shoulder, and other areas in the bottom corner it's the full height. And the mold is reused many times, so it's very cost effective. The contractors liked it because it didn't slow down production. There is a bit of prep work, but that can be done like inland. It's not a critical path, so it doesn't slow down the production. And the contractors on site actually took ownership for it. Before they knew who I was, I used to go out on site and check what was going on, and they'd start telling me, do you know what we're doing? We're building this to, you know, create habitat. And it was really great because then they really, I knew that they were taking ownership of it, but they were really proud of what they were doing, and it really made a difference to the, you know, kind of the whole feel on site, which was great. So the colonization, initially we got the small hydrobia, I think they're not called that anymore, marine snails. And then we got the ulva moving in, which is a colonizing seaweed, but we've got really high nutrient levels in the Solent and particularly in Langston Harbour. So that's quite dominant along there. We started to see the difference in areas between the smooth and the textured surface, and that's kind of moving along. So where it's lower in the tidal frame, we've got this kind of growth of ulva going on. And now recently we've just got the fucoids, the brown seaweeds coming in. This is the target seaweed that we wanted to grow. Obviously we have constructed a defence. It's going to impact the foreshore, so it's taking a little while for it to colonize. We had to work on the foreshore in areas because we couldn't work from behind. We did limit that. We've got the nutrient levels, and also I need to be patient. It's time taking for it to grow. The design itself, as I said, was based on this PhD research. So we created different niches for different species. So the seaweeds can grow on areas where the grazers, like the limpets, can't grow them, so they won't eat them off the wall. It's quite complex. So you can see here the difference between the texture and the smooth, as the texture is really starting to show at all levels of the tidal frame. Obviously the lower in the tidal frame, that it is easier to grow. It's starting to show that it's really working. So texture is definitely the key. Also saying what we really want to see is the kind of asset resilience. So once you get the seaweeds growing on the wall, underneath, it keeps it moist and it keeps the temperature consistent. So this really shows how it makes the wall will last longer. It absorbs the wave energy and it stops this constant drying of the wall, wetting of the wall, which reduces the asset resilience. So it should increase the asset resilience. And we are doing more studies on that. The limpets have now moved in, and they're cleaning the areas that are smooth, which is what we designed them for, but then don't seem to be eating on the other areas, which is great because that's also what we designed it for. Another intervention that we did was a high tide wader roost island. This area is a SPA, so it's, as we couldn't work in the winter, for designated for overwintering birds. The limiting factor on the population is that they have got nowhere in the winter, these birds, to roost. We've got such high levels of population that when the tide's in, they've got nowhere to go inland, and they get really disturbed by dogs and people on fields or anywhere where they're trying to go. So we initially tried to look at just utilising the foundation of the wall, but actually Natural England said, could you make it bigger and move it out into the harbour, which had additional issues on the construction, but it worked well. So initially we had the wall was in place and we built the island, as you can kind of see the various processes going through. And then this photo here in the bottom, you can see where the wall was, and then we moved it to the inland bit, so it effectively moved the island offshore more. And we're getting, the birds are starting to use it. They usually take a while. They're quite nervous of using new structures, but they are using it, which is great. And linking into what we were saying earlier about trying to get the people involved. So we're putting interpretation out. We're trying to make it a bit more inclusive and interactive. So we've got Braille going onto the interpretation, and also QR codes, so people can hopefully stop, listen to the sounds of the birds. They're quite far out now and they're really tiny, so they're very hard to see. So we're trying to get people to listen for the birds and understand as a focal point how they can be a bit more responsible. So, you know, there's always all aspects of it. And I just wanted to try and give you a flavour of what we've done. We've done lots of other things on schemes, but you know, every scheme there's always a solution. I don't think we can ever say, no, we can't do anything. There's always something that we can do. So I hope we've given you a bit of a flavour for that. Thank you.
Thank you so much, Lucy. So we're now going to hear from our final speaker, Nikolai Rotterman, who's a Senior Teaching Fellow at the University of Portsmouth, who's going to be looking at lead planning and monitoring at the North Portsea Coastal Scheme. So, over to you.
Great. Hi, everyone. Can you hear me at the back? I know the aircon has kicked in again and we can't seem to find someone to switch it off, so apologies for that. How this all started is there was an opportunity for us to work with coastal partners to do some monitoring on this exciting new construction, the North Portsea Island scheme. And I should say right now, apologies from my colleague, Fran Cabada-Blanco, who's sort of co-run the Portsmouth side of this. She's sadly out on a field trip with students in Bali right now. So she's really gutted she can't be here today. But what we wanted to do on the Portsmouth side was integrate the monitoring of the seawall into our annual student projects. And that way we can really start to develop a long-term data set to monitor the changes for a scheme that's really designed to be built with a 100-year life cycle. You know, the scheme is designed to be built taking into account that sea level will potentially rise quite substantially. So that's what we're going to do. And what I want to talk about really just quickly is just give you a run through of some of the monitoring that we are doing, some very initial data, and then talk about where we're taking things forward from here. So, oh yeah, okay, well, I'll start with this. I seem to be missing a slide, but that's okay. Basically, you've already seen in the previous presentation the layout of the eco formliners, and because these eco formliners are in little segments, there are little gaps with smooth wall, and that gives us an opportunity to do some comparative data collection to compare sterile smooth surface with the eco formliner textured surfaces. So essentially what's gone on here is we have so we are missing a slide for some reason. Basically, we chose 9 monitoring stations along a stretch, the phase 4 of the North Portsea Coastal Scheme, and that comprised 4 years of construction. And it means that we can sort of look at that colonization process of that time period. Within each station, we are obviously understanding that depth or height above sea level is quite a critical variable here. Is we have chosen quadrats to be positioned above and below this ledge. This ledge is at a consistent height relative to sea level. Okay, so 2.3 meters above ordnance datum. And then depending on where we are, which station, because some stations are positioned lower than others. So this little station here is right at the top end where there's a lot of gravel that's quite high up. So we only have a little bit of ledge. And basically the sea isn't coming above this ledge. So you can see how sterile the upper section is, but obviously this is built with 100 years of sea level rise taken into account. So we're taking quadrats. These are just quadrats along the textured surfaces, and then we're also doing quadrats on the smooth sections as well. Trying to get lots of small quadrats, and the horizontal positioning of these quadrats are randomly chosen. So we're trying to get lots and lots of replication in there, and we're trying to have a methodology that's really nice and consistent so that every year our new batch of undergraduate students as well as master students can learn the skills really quickly and then get data that is comparable year on year. And that's the priority for us, is getting a robust data set over time. So intuitively, and again from the previous presentation, you can see that there are differences between the textured sections and the smooth sections. And this is a bit of the phase 2, the second section, the 2022 build rather than the 2021 build of phase 4. And one of the big things we've noticed, obviously, is that the first colonization is this green algal mat, which is a combination of over several other genera of green algae. And you'll go out today, you're going to see the mudflats completely covered in these algal mats. And this is really a function of the large nutrient input into Langston Harbour, and that's a challenge that we have to deal with. And we don't really know at this stage how that impacts the growth of the fucoid algae, which is really the target species that we want to have growing on these seawalls. So we don't know if it's really impeding. We are looking into that. I just wanted to show you a couple of plots, actually an output from one of my undergraduate students last year, comparing textured versus smooth sections of the seawall. And these are depths in relation, relative heights above and below. So 30 centimeters above and then 30, 60, 90, and 120 centimeters below the ledge. So as you go lower down on the seawall, there's a lot more biology, and that makes sense because the submergence time is longer in the tidal cycle. But we can see a difference between the textured versus the smooth. And this is all very, very initial data. So most of this is really relating to the green algal mats and then the things that are feeding off the green algal mats, because we haven't had the time yet for all of the fucoid colonization. So higher species richness on the textured side versus the smooth side, higher species abundance on the textured side versus the smooth side, although slightly less compelling at this stage. I wanted to point out that this is a 2021 phase of construction, and this is a 2022 phase of construction. And you would expect the earlier phase to have a lot more biology on it. We found the opposite, and that's because that 2022 phase of construction is lower down. So there is much more of the seawall that is submerged for much longer. But also, we noticed that on this section, the substrate at the base of the seawall was sand and gravel, as opposed to fine mud with lots of fucoid algae around the base of the seawall. So that's another thing we're looking into, is how connectivity between the intertidal zone and the seawall enhances that colonization process. And again, some pictures just to show that we are now getting that fucoid algal recruitment. And you can see a difference at the base here between the smooth sections and the textured sections. And obviously that texturing is helping the fucoid algae get that foothold. And obviously water retention has got to be a big factor. You can see how much higher the algal mats are relative to the smooth sections. So there is a difference. We hope to see that difference become more stark as time goes on. You can also see the effects of grazing from limpets on those smooth sections as opposed to the textured sections. So that idea, that hypothesis seems to be bearing out, that these smooth sections will be grazed. So these smooth sections aren't intentional. They're just a byproduct of the constraints of that design process, but it was an opportunity for us to therefore compare smooth versus textured in the same location with the same orientation. So what are we looking at now? And this is something that's primarily being driven by Fran, who's not here today, but we are looking at ways of enhancing, and that involves temporarily affixing fucoids attached to pebbles that are then epoxied onto parts of the seawall, and then comparing that with areas where the green algae have been completely removed, totally sterile areas, areas where we've just put the shingle pebbles without the fucoids attached as well for controls, doing lots of replication. And things that we're noticing obviously is that one of the most important things is the height above, or the height in relation to the seawall ledge is critical for that fucoid algae. If it's a bit too high, it just dries out and you don't really get anything happening there. So this is very early days. We've only just had one season of data collection. And so Fran's students are currently working up that data right now. So hopefully we'll start to see some differences. But you know, everything is looking quite encouraging at this point. So yeah, conclusions. We do seem to see some enhancement of the algal colonization. I think this is primarily due to water retention, and any ways that we can enhance water retention is going to be a good thing. But also some of that complexity is allowing some of those surfaces of potentially allowing fucoid algae to colonize. But we do think that connectivity is really, really important. That connectivity with the foreshore is quite critical. And then obviously height above chart datum. Orientation, we do notice some difference between the sides that are slightly less or slightly more south facing. So there's slightly more south facing segments of that wall getting a bit more sun, so they're drying out more quickly. And you might even notice that today. So there's a lot of, location complexity built in, but hopefully we're going to be building on the existing sampling strategy so that we will have a really, really long data set to compare with. And that's it. Thank you very much.
Thank you very much, Nicola. So I believe we're now done with the presentations and we'll be hosting the Q&A session. So if I could invite all of the speakers just up to the front, and I'm going to try and bounce between questions in the audience and some of the ones that have come through online. So if anyone has been holding on to any questions, then now's the time to ask away. Just raise your hand. Yes.
Just in relation to environmental consultancy, in relation to the work that we've done, particularly the high tide research, I'd love to look at how you the HRA process and the licensing of that particular.
So we are very tightly regulated on that, clearly, because it's SPA and a SAC. We actually removed an old quay just slightly further. I can show you if you're coming up the site visit, literally next door to it. So we released a huge amount of intertidal area before. So literally, we've got more mud than we had anything else. And naturally, they actually said, can you make the bird island bigger? Which was a bit of a shock to us, to be honest, but it is the limiting factor for the SPA. And because we've released the additional area of mud, we could make it work, on a spreadsheet, if you like. Yeah, so that's how we did it.
Any other questions? Yes.
Curious about the actual seawall, like the material of the concrete, releaser. So I assume you're engaging with material makers that can focus on carbon material.
the North Port Salem scheme, we did look at that. We couldn't actually get it to work within the budget that we had. So it was just the standard concrete. It's literally a very small, I mean, literally tiny additional bit of concrete, but obviously it is over a long period, a long length of wall. But what we're thinking is because the seaweed is growing on the wall, it should actually increase the longevity. And that's one of the things that we're going to be working with Portsmouth with, putting some blocks out to see actually how much it will increase the longevity of the wall. So hopefully the wall will last longer, provided it's high enough for sea level rise. But also there's a lot of work that's been done on kelp to show how it's very good at storing carbon. It's quite a long, complex process. It's not so easy as just looking it up in sediment, but hopefully when it's got the seaweed growing on it, that'll offset some concrete. And relatively to the size of the scheme and the amount of concrete that we've put in, it's tiny, that additional bit. And hopefully we really tried to do it, but we couldn't get the mix to work on site in a cost-effective way. I mean, ultimately it always comes down to cost, but we really tried, but we just couldn't get it to work. So hopefully things have moved on now. Yeah.
Just going to take a question online. I think.
Jack,
Yes.
I wanted to come into that question, please.
Yes. Yeah. Go ahead.
Okay, so just for the question around asset resilience, there's been much more limited research on bioprotection, and Lucy and I have worked really hard to get these blocks that she just referred to on into the intertidal, so that they can be destructively sampled, but can be at the scale of engineering. So Harriet Watt engineers were involved, and trying to have a method by which you could put sensors in the blocks, which they've done on certain sites. So one of the things that's nice about this guidance coming to fruition and all of these schemes is that there's a real need to work with people like myself who are rock weathering geomorphologists who understand, and my whole PhD was on rock biotic interactions, for example, alongside material scientists and engineers. But we need the schemes, but we also need the schemes where it's safe from a human access point of view, which is one of the challenges in Portsmouth, and theft, to actually put out some instruments within the sacrificial blocks, as it were. But the research that we've done, and with Martin Coombs, was my PhD student and postdoc at Exeter and Oxford, is the kind of UK work on bioprotection. Jess Bone wrote a review recently of bioprotection, but there's work by engineers in Japan, and there's also some work done in America. And so I think it's important to think about greening the grey, and as you know, some of it will be very green, like a lot of fucoids, but some of it might be actually a lot of barnacle cover in places where you won't get fucoids. If you have really high barnacle cover, then the chloride ingress behind the seawall is much lower. So the evidence is really encouraging, but needs more work and more partners and collaborative projects.
Thank you, Larissa. Just to take a question from the online audience, we've got one here saying, how do we ensure that these interventions are seen as truly valuable at the appraisal stage, rather than seen as a costly add-on to the scheme? Is this about quantifying benefits and demonstrating value in a way that FCRIA appraisal recognises? Yeah, go ahead, Larissa.
Sorry, just to say, so there's a 2017 guidance that was called Greening the Grey Report, which Lucy used as a catalyst to get the scheme that you're going to see today off the ground with myself. But that had a business case in it, which mirrors the business case that comes out in the new guidance. And that came from Jonathan Sim, who's done a lot of guidance and appraisals. And there was a partner project on river bioengineering, green engineering at the same time. And so both projects had that appraisal, and that original guidance, or not guidance, but like kind of case studies, and kind of, it was to sort of set up a business case. And we used a semi-quantitative ecosystem services approach, that's kind of been mirrored in this new guidance, but taking that forward. But there is a need again to kind of, how do we interface this more? Can biodiversity net gain calculations and ecometrics tool that Nick White produced for Natural England, and he was on the steering group of the Green Grey report from 2017. So there's, you know, there's again needing to be more kind of joining up across silos and sectors, I think, but there's a real opportunity to, and that was the whole purpose, was to help keep it on the table early in the construction phase. And things like changing tenders are another place in the process. And a lot of those are not necessarily expensive if you're using rock armor and passive enhancement, for example.
Thank you. Not sure if any of the other speakers had anything to add to that.
Yeah, it's important to recognise sort of that business case process, that integrating the eco-engineering right from the start is really key and critical, and really seeing that strategic context and how it fits into all the different partners that are involved in the project, how it fits into their objectives and local strategies, etc. Then it really sort of anchors it into the project, rather than it being an add-on at the end or a nice to have, or it's the right thing to do. It really kind of brings it into the project as a whole, and feeding it through into the project objectives and the critical success factors to ensure that as the option appraisal is done on the options, that those eco objectives are really keyed into the whole project, so that it helps support the inclusion of those eco engineering measures going forward.
Yeah, thank you. Just to take another one from the online audience, I think this is regarding the North Portsea scheme. How does the seawall get checked for failures and defects without actually disturbing or harming the communities that have established there?
Yeah, so this is always raised, but everybody always asks me. I always go back to our asset inspection team and say, are there any concerns? And they're like, they don't see it as an issue at all. So from the regard to the monitoring the wall going forward, we're doing much more drone surveys to see if there's any movement in the wall and those types of things. If they need to go and check a particular bit, so they've noticed a movement in the wall from the drone surveys, they can go and clean a bit of the wall off. It's an ephemeral, opportunistic, you know, those species are ephemeral, they're opportunistic. If we had to remove it off a section of wall, it'll come back. It's just not a biggie. It should never stop this type of thing taking place, you know. So our asset engineers are totally fine with it. Yeah.
And very quickly to say, I think I often get lots of questions about that, and I think the original work, PhD of Martin Coombs that I worked on, it was William Alsop was brought in as, you know, an expert in engineering of hard structures and breakwaters and things, and he said there's a British standard, and there's a British standard for the icing on the cake. And we're talking about, you know, a small amount of change over 150 years. If you look at Plymouth Breakwater, where they put granite and limestone. So it's bearing that in mind, but also drawing on. And I'd like, you know, to get a project where there's a lot of really innovation in non-destructive testing in the historic built environment. It has a lot of stone decay, and that hasn't ported across. So can we use different techniques? But other engineers I spoke to said we're actually looking for bigger cracks, so we don't really need to scrape away the seaweeds that might be providing the bioprotection to actually figure out if the assets, like Lucy said with the drones. So I think there's a space for real innovation, and maybe some kind of something to support helping have those conversations in a meaningful way. And Lucy's got great engineers who are willing to talk about that.
Thank you. We'll take another question from the audience.
Sorry. Speak at the back of the room. Can't help that. Hear very well, and the microphone's not picking you all. That includes Marissa on the screen, if possible. Thank you.
Okay. Yes.
Yes, question at verticals. And from the slide you had, there were eco-concrete and the anthropology. Yeah. Sorry. And yeah, so the eco-concrete structure looked as though it had was smooth, okay, and the anthropology principle is a much more textured. Is there a difference in terms of polarization between the two? Is one better than the other? You spoke about complexity leading to increased habitat.
Yeah, so say the tide pools are bigger units, but yet there's a lot more kind of smaller surface in the land, and they can have protection on the outside and inside for the privacy benefits. So yeah, they have high species which is variety species as well.
Anthropology of here, by the way.
Yes.
Yeah.
Yeah, we have two different anthropology verticals together. So it spreads the air. We try to cluster them as close together as possible, but with the fact that it's actually integrated into the river, then we could really put them as close as we wanted to. But I mean, it's still been great.
Is there an argument for making the tide pools with a bit past? I suppose it is.
I guess it maybe comes back to cost as well, because the size that they're acting as the method kind of just make wave energy, whereas the verticals are on the side to kind of enhance the vertical sequence. So yeah.
It can certainly be revisited and enhanced. There's no problem with that at all. We're working with QVEX who've been producing beautiful hexagonal pools. Walls that are incredibly strong, and then hand applying the detail inside. And I know everybody will go, you know, oh, that sounds slow, expensive, etc. It's really not, because of the materials that we use. We have to work fast. You have 10 minutes set time, but that's how long it takes. And we, over the decade and a bit that we've been doing this work, the energy has gone into learning how to do that. Sets that fast. But get a kind of complexity that you just can't get through molding or even 3D printing, particularly random nature with these 3D printers. This is from my hand to my feet, I've got about 30 degrees of freedom. A 3D printer generally wants 6 maybe. So I can go nuts, and I've got 2 working in tandem. So the amount of detail that we can that can be told anyway, so they can go to that side between tides because you've got and we've been trying that as well.
I can just add in just a little additional element is people like my colleague Fran, who's specializing in looking at habitat complexity in a coral reef setting. We can use techniques like 3D scanning or laser mapping to quantify that complexity. And then we can, and something that we're sort of interested in looking into is how we can quantify that complexity to then look at to show the ecological benefits of that complexity in an artificial setting.
Yeah, thank you. Another one from you? Yes.
So were those examples of concrete net from habitats in the crane, is there a similar
So just to repeat that for the online audience, it was a question about if there are examples of steel eco-engineering methods. So is there one of you answers? No.
I can answer that if you like.
Oh, go ahead. Yeah.
Yes. Yeah. So I mean, because of that way of working that I've just been describing, we can work with any material. So we have a couple of ones that through our team that have now been deployed steel, but have even charcoal. It's a super magnets. Really makes it cheap.
The other thing I'd like to really do on that is like make those things that you could take off like an anode, so that would be the sacrificial bit, and then you can make the wall last longer. So it's kind of thinking, trying to get multi-purpose things after those types of things. So if you want to try something, sure you can work it out.
Larissa, is your hand still raised from earlier? Yeah, okay.
I just was going to answer the last question that's in the online. So interestingly, they said any impacts from floating refuse or debris. And the Sheldon scheme, which was one of the first ones that I advised on, which was linked to Martin Coombs's PhD, is we created it was, you wouldn't get this now, it was like stone cladding in front of a wall because it was a conservation area, and now just like the money just probably isn't there. But what we did is they left out some rock, some cladding rocks, stones, and created little pools. And they saw, you know, those sometimes the odd person put like a Coke can or whatever in them. And one of the things that nearly caused a problem with the Portsmouth scheme was, would people use it as a climbing wall? And so then we checked all the designs. So I think there are some like where there could be human intervention, but I'm not aware of any that have had like what you're talking about is waste. But the other thing that's a major consideration about where it's ecologically appropriate is there's a lot of abrasion on much more active coasts. And so it's really important to think about the geomorphology and what's going on with the geomorphology and whether that is conducive to being suitable for habitat. And so I would just implore that there needs to be not just marine ecologists on teams, but coastal geomorphologists, and particularly ones that understand our biogeomorphologists. And for example, at the Hartlepool scheme, we said, you know, they had to use Shap granite, which is pink and lighter in color, because again, rock weathering science, that's a lower albedo, so it's gonna be you're less likely to fry your limpets when you have a heat dome like we've had in France, moving forward over that design life. But equally, they were putting that granite on magnesium limestone. And so if you get to a point where that structure that rock armor unit in front of the wall starts to fail, you're talking about like, you know, you're grinding like a hard rock against like a crunchy bar, right? So you know, you've got to be really careful in that context as well, that the rock that you use is geomorphologically suitable, not just ecologically suitable.
Thank you, Larissa. I suppose a slightly selfish question, as we've recently started a project on offshore infrastructure and sort of good practice in that side of things, looking at wind farms and that. I suppose combining the two topics, is there a chance that there's sort of extra research in the space of offshore infrastructure, combining that with eco-engineering at all?
There's obviously potential to use eco-engineering in offshore. There's a few projects that are ongoing looking at that, like scout protection. Yeah, there's some techniques that could be.
Crown Estate just recently announced their big pool of money for offshore projects as well. You know, floating farm, Atlantic Sea, it's like £50 million from various.
Okay.
Yeah, the Insight project looks at this a lot, and biomass, which is valuing marine artificial structures. That's a NERC project that will be starting very soon. So I've just been to the Structures and Marine Environment Conference where they talked about this entire topic quite extensively. So yeah, there's a lot of application offshore as well. Yeah.
Cool, brilliant. Right, I believe probably got time for one more question, so I'll just take, yes, you sir.
In terms of maintenance, probably make sure that the good work is done, sort of undone by sort of routine engineering maintenance of boulders that we moved around. And then secondly, on the funding, what's your main source of funding? If it's the business case that you're developing, how much of that is partners funding? How far do you go to find partners to fund certain schemes?
from the maintenance point of view, were you just talking about the rock revetment type?
Yeah, yeah.
From the South Sea scheme, it's been where we put the tide pools in. It's been designed that if something happens to those, the rock will just fall into the place. That's how it's been designed. So there will be no going back out, whatever happens, onto the revetments. They're also, you know, scaled large enough, the rocks to not move. That's the aim. But obviously they would move if something happens to the artificial pools within that area, which is why actually they would only do a certain amount in any location, the engineers. From the point of view of funding from our schemes, that is a huge amount of my time, is to try and get funding, and that's the most frustrating part of the whole process. People, once you get them on board, they're really keen to get involved, from the contractors, the engineers, everybody's really, you know, like wants to make a difference, but the funding is a constant churning, and it's got a time, you know, tie up. The RFCC have been great. They've funded it bits and pieces. The Environment Agency from the Water Environment Improvement Fund. So we've had local levy. Natural England put a bid in, and I've just managed to find it from various pots. But it is a constant battle. And this project has been going on quite a long time, but hopefully we're starting to see that people are seeing the value of it, and it will be, you know, kind of, ideally you'd have it in the whole business case going forward, but on the North Portsea scheme, it wasn't, so that it wasn't really, eco-engineering wasn't really a thing when we put the business case in, because it was a long time ago, because these projects take years to get through the whole funding process and stuff like that. So yeah, hopefully going forward things will be a bit more, I'd like to say seamless, but we'll see.
Larissa, I see you've just raised your hand. We're just about to close the Q&A session, so if it could just be quick.
Yeah, so very briefly, just to say, from the research side, the majority of this has been funded through not the UK government research councils. And when we did have some money for that enabled us to work really well with Lucy. There has been some DEFRA funding, but it's mainly been like EU or other sources of funding, biodiversity, Nature Scott. So there's potential opportunity to try to again collaborate and try to think about how do we harness you know, non-conventional sources of funding that could support this, like non-conventional from a flood risk point of view, and how can we, you know, make that work better. And urban green infrastructure is potentially an untapped way of going about these things if they're in very urban places as well, and stretching urban green infrastructure into the coast, which is little done.
Brilliant. Thank you very much, Larissa. Right, so that brings us to the end of the Q&A session, and thank you again for everyone who's attended today for the launch. Larissa, Joanne, Emma, Anira, Lucy, and Nicola, thank you for your valuable contributions and presentations. We are going to circulate a link to the presentations after the event, and we will endeavour to get to any questions. If you do think of anything else, feel free, you guys can ask them today, but for the online audience, if you have any other questions, feel free to send them our way and we'll get a good answer for you. Right, so I believe now for the online audience, there's going to be a poll that's going to pop up on your screen, and if you want to fill that in, that will help you get your CPD for the event. And while that's running, for the benefit of the people in the room, just to remind you that there is a delegate offer for the guide running until the 15th of July. So you can get 20% off the price of the guidance by entering the code C820 at checkout. And to order the publication, just visit the CIRIA bookshop on our website. And discounts are available for multiple purchases. So email inquiries@ciria.org for more details on that. But that does bring us to the end of today's event. So it's where we part ways, unfortunately, with our online audience. So just a final thank you to all of our speakers and to the University of Portsmouth and Coastal Partners for helping us facilitate today. And thank you for tuning in online, and thanks for coming in person. So I do hope to see you at another CIRIA event. And yeah, it'd be brilliant to see you in the afternoon for the site visit. Thank you.